Okay, welcome to Introduction to Complex Numbers. This is the start of our new unit, Unit 2. So go ahead and write that down as your title for today's notes. Okay, we're going to start off with some vocabulary, imaginary numbers. Okay, imaginary numbers is our vocabulary word, and that is notated by this I that we see. Okay, and what are imaginary numbers? Well, they are when we're taking the square root of a negative number. This is what we use to find the solution. Okay, so something that we have been saying since Algebra 1, maybe even before that, is that you cannot take the square root of a negative number, which was true in Algebra 1. But now that we're in Algebra 2, we have a way of taking the square root of a negative number. It's going to be an imaginary number. It's not going to be a real solution, okay? It's not a real solution, but it will give us an imaginary solution, okay? And so that imaginary solution is the I. And I is equal to negative, the square root of -1, okay? The square root of -1. So let's talk about, how can we see variations of I, okay? Of I. So if I is equal to the square root of -1, well, what is I squared equal to? Okay, well, then that would mean we would have the square root of -1 squared. Okay, and we could have this bit of a conversation real quick about the square root and this squared. These guys are inverse operations, if you will. You know how we had multiplication and division are inverse operations, addition and subtraction. Subtraction is inverse operations. Well, the square roots, okay, in the square are inverse operations. Why? Because back when you learned what a square root was, they told you there was an imaginary 2 there, okay? So for example, I know that the square root of 9 is 3, right? And I know that 3 squared is 9. So if I want to say, what is the square root of 3 squared? Well, then that will be the square root of 9, which is 3. So they're opposites of each other. They essentially cancel each other out. So this will be canceled out with this. Okay? So in that case of having that bit of a conversation, I would advise you to pause the video so you can write this down, because in a moment I will be erasing. Okay, so in the bit of us just talking about that, we need to know that these two things will cancel each other out, okay, leaving us with -1, what was originally inside of the square root. So that means that I squared, let's write that out really better than that I squared is equal to -1, okay? So then what about I cubed, or to the third power? Well, we would write that as I squared times I. So every time we are working with I, the pattern is, okay, that pattern is that we're going to be using I squared as a base. Okay, what does that mean? It means that every time we're trying to figure out a higher degree of I, in this case I to the third power, we're going to use I squared. Okay, so in this case it will be I squared times I, with this I having an exponent of 1. Because remember, when we multiply, going back to our law of powers, that 2 plus 1 is going to be 3. Okay, so every time we're working with I, the pattern is I squared as its base. So in that case, now I'm going to move this just for a second because we're going to try that one in just a little bit. In that case, we have I squared times I. Well, then we just said I squared was -1, okay, times I. Okay, now we don't have to necessarily write out this, that I is the square root of -1. Okay, either this answer or recognizing that I itself is -1, we could write it as either one. But the way that they will prefer you to answer this is that it's going to be -I. Okay, so each time that we are trying to find a higher power of I, as an example, we use I squared as the base. So I want you to pause the video and try I to the 24th. Again, pause the video. Okay, so hopefully you paused the video. So if we're thinking about this, we could say I2 times I2 times I2, etc., right? But we don't really want to do that in order to solve this. We could do something a lot easier, okay? A lot easier. Instead of having to do I2, I2, I2. We can recognize that I squared, okay, times 12. So this is where we need to go back into this law. So this law of product of powers that tells us when we have x to the m in parentheses raised to a power of n, it means that we can do m times n. So in this case, 2 times 12 would get us back to this 24. So I could write it like this. And I know that I squared, okay, is -1. We know that already. Okay, so then I could say -1 to the 12th power. Now, do we really want to do -1 12 times? No, we can recognize that anytime we have an even, okay, anytime we have an even exponent, that our answer should be positive. So this answer should come out to be +1. Now, if it was an odd exponent, then it would come out to be negative. So the answer to I to the 24 is 1. But you could use that law of product of powers in order to figure it out based on the idea that we already know that I squared is -1. Like that one should be in your memory. Okay, so I advise you to pause the video so you can get a chance to write that down and kind of process what just happened. Okay, hopefully you paused the video. So now let's get into this understanding of what I just said about this I. We just said that I is when we're using that when we're trying to figure out what's the square root of a negative number. So let's try to simplify one that is not a perfect square. Okay, remember our perfect squares. Like 1 squared is 1, 2 squared is 4, 3 squared is 9, etc., right? So this is not a perfect square. No two numbers. Remember when you're taking the square root, you're trying to find two numbers that gives you that same thing underneath the square root. And we don't have two numbers that's going to be perfect, right? But we can break it down into two perfect squares. And so I would find two numbers that multiply to 50 in order to, one of them needs to be a perfect square. So if I write out all my perfect squares, I'm going to keep writing them out just for purposes so that we can do this. 4 squared is 16, 5 squared is 25. I can pause at 25 because I should know that 25 times 2 gives me 50. And 25 is a perfect square, okay? And so the square root of 25, we know that is 5. And we still have this square root of 2. So this should be familiar to us from Algebra 1 on how to simplify and break down a square root. So in this case, it's 5 square root of 2. But what happens if you need to pause the video? Go ahead and pause the video because I'm getting ready to change the screens. But what happens when I have a negative number? Remember we just talked about we use I when we have a negative square root, right? And so I do. So one of the first steps is to use the I. In that case, I'm going to say that this is the same thing as -1 times 50, right? Okay, and so then let's break that down. That's the square root of -1 times the square root of 50. Well, didn't we say that the square root of 1 is I? Okay, remind ourselves that I is the square root of -1. Okay, so then that means this is I. And now I have the square root of 50. Well, we just did that on the previous slide. And we found and broke that down already. So we know that to break this down even further, we would say that this is a 5 square root of 2, what we just got on the previous screen. Okay? So then when I simplify this out, it's going to be 5i, because we always write the coefficient in the front, 5i square root of 2. Similar answer that we just got, but in this case, we're using I because we're trying to figure out the solution to this negative square root. Remember, this is a real solution. Okay, this is a real solution, and that this is not a real solution. Okay, this is an imaginary solution. This is not real solution. Okay, because we had to use the imaginary number I in order to solve it. Okay, so pause the video, and you do this one and break this down. Okay, you try this one, so pause the video. All right, hopefully you paused the video. So one of the conversations we just had is that when we have a negative number, we can go ahead and pull that I out, okay? Just like we just did on this previous screen, we're going to go ahead and pull this I out to begin with and then break down the square root of 27. So on this point, you should be writing down your perfect squares every time until you have them to memory. Hopefully, at some point you will have them to memory. And I could realize that, okay, 9 and 3, 9 times 3 gives me 27. I could break that down like that. And I know that the perfect square is 9. And so the square root of 9 is 3. So I know that this inside part in the parentheses is 3 square root of 3. Okay, and to rewrite that, I go ahead and write that in front of my I. So hopefully you paused the video and you were able to get that right. Okay, this is a listening check. This is a listening check. Go ahead and circle the perfect squares that I wrote down. Go ahead and circle the perfect squares that I wrote down. This is a listening check. So again, this is a listening check. Go ahead and circle those perfect squares that I wrote down. Okay, so let's move on. We said this was introduction to complex of numbers. What does that mean? Well, complex numbers are numbers of the form A plus BI, where A and B are the real numbers and I is the imaginary number, okay? So here are some examples of this form. So you know how we had standard form? Okay, this is like a standard form for polynomials. Well, this is like a standard form, but it's called complex form, okay? Like this is the complex form. So it's similar to standard form, okay? And so this version of standard form writes the number first, and the part that has the I attached to it is written second, okay? So for example, 3 minus 5i. It will not be an example if I wrote it like this. This will not be in there. Negative 5i plus 3. This is wrong, okay? You must write it like this, where the number is written first, the A, and then the number that's in front of the I, which is B, is written second, okay? So go ahead and pause the video so you can write down that vocabulary. And let's talk about adding complex numbers now, okay? So now that we know what they are, we have operations with them like we had polynomials, okay? We did adding, subtracting, multiplying, and long division, okay? We're going to do the same thing but with complex numbers, and let's start off with adding. So we're going to do this one. And what I like about this is that is very simple. You just have to match your like terms. It goes back to like terms, okay? So here's where your two colors comes in handy. So I'm going to mark what my like terms are to begin with, okay? So obviously I'm going to match my constants with my constants and with my i's with my i's, okay? So 3 plus 7 is going to give me 10. That's my constant. And then my other like terms were 5i plus a negative 2i, okay? And that's going to give me 3i. So together, to write that in standard form, I would write my 10 first. Okay, remember the A has to go first, the constant, plus my 3i. Okay, and that will be my final answer. It's very simple. It's not hard. It's like terms, like with polynomials. You just need to match them. Okay, so pause the video so you can write that down. Process what happened. Use your two colors. And then I want you to try this one. Okay, try this one. So hopefully you pause the video. And this way, in my showing my work and showing my work, I went ahead and lined it up like I did with adding and subtracting. This is a listening check. This is a listening check. Go ahead and draw a star. Go ahead and draw a star next to that lineup process. Go ahead and draw a star next to that lineup process. Okay, so as I was saying, you're going to go ahead and line it up, match your like terms, use your two colors. 7 plus 4 is 11, and 5 plus -8 is -3. And that's your final answer, okay? Let's do another one. This time we have, it looks a little bit different as our setup. Let's notice that we have an exponent here. We're still adding, but we have an exponent. And remember with PEMDAS, we're going to follow PEMDAS the same, that it tells us to do our exponent. So we want to tell ourselves that this is 5 squared times I squared. Okay, that square goes to both of them. Okay, it goes to both of them. Plus 3 minus 4I. So 5 squared is 25. Okay, and we said at the beginning of the video that I squared, okay, was -1. We said that at the beginning of the video, that I squared was -1. Okay, plus our other complex number. Okay, and then we're going to multiply. So 25 times, there's like a times right here when you see parentheses. -1 is -25. Okay, again, plus our other complex number. And then you want to tell yourself, well, what are my like terms? Well, this -25 and this +3 are my like terms that I'm going to combine. Okay, so -25 plus 3 is -22. And so I have -22, okay, minus 4I. And that will be my final answer. Okay, so again, it's just reminding yourself of this 2 at the beginning that we had is both to the 5 and the I. Okay, it's to both of them. So go ahead and pause the video. Pause the video. Process it, because guess what? You do this one. Okay, so pause the video and try it. Pause the video and try it. Okay, hopefully you tried it. So same thing. This 2 goes to both the 2 and the I. So I have 2 squared times I squared. 2 squared is 4, and we already know that I squared is -1. That should come to memory. And that we know that 4 times -1 is -4. Okay? This is a listening check. This is a listening check. Go ahead and spell out the word orange. Spell out the word orange on this slide. Spell out the word orange on this slide. Okay, so -4 plus 5 minus 3I. So we're going to continue with that and combine our like terms. I mean, I lined them up. But -4 plus 5 is +1, and we still have our minus 3I. That is my final answer. So go ahead and pause the video if you need to finish writing that down. Okay, so we're done adding. Now let's do some subtracting. It should be similar to, again, when we did polynomials in this last unit, where you are changing the signs, okay? So you're distributing this negative sign and changing the signs. So this becomes a plus on the outside, because remember, all subtracting problems become addition problems. And you have -7 plus 2I. Okay, I changed the sign. So 7 was positive, it's now negative. And negative 2 is now positive 2. Okay? And then you're going to combine your like terms. So this guy with this guy. So 3 plus a negative 7 is equal to negative 4. Okay? And a negative 5i plus 2i is equal to negative 3i. So when we want to write our final answer out, it should be negative 4 minus 3i. Okay? So again, remember to distribute your signs. Okay, distribute your signs, that negative sign, and change the signs. Okay. So now pause the video and you try, you do. No, really, you do. Okay, so hopefully you pause the video. The first step, again, remember, is to distribute that negative sign and change the signs. So it's going to be negative 6 and negative 12. And all subtracting problems become addition problems. Let's combine our like terms by lining everybody up. And positive 3 plus a negative 6 is negative 3. And negative 8 plus a negative 12 is negative 20. That will be my final answer. Okay, so let's try this one that's more complex a little bit. Okay, we're going to add all of our skills together, reminding ourselves first and foremost that that 2 goes to both of my terms. Okay, goes to both of my terms. Now notice something. This is not in order, right? Because it should be the number first and then the I. So let's change that. Okay? This needs to be in standard form kind of thing. Like this is a standard form of complex numbers. Remember, it's A plus BI. So we need to change that, okay, to 6 minus 2y. And we need to change our signs, distribute that negative. So it's a lot going on in this problem. Remember, it's going to change to plus out here. And this is now positive I minus 3. But remember, we need it to be in standard form. So we need to change that as well to negative 3 plus I. Okay? So let me pause there because there's a lot going on. Process, pause. Okay, negative 5 squared is going to be 25. And we knew that I squared is negative 1. Hopefully we know that by now. And we still have this here. So 25 times negative 1 is going to be negative 25. All right. Plus 6 minus 2i plus negative 3 plus I. Okay, I'm going to combine all my like terms, so negative 25 plus 6 and minus 3. Okay, negative 25 plus 6 and minus 3. Okay, negative 25 plus 6 is negative 19. Minus 3 is negative 22. Okay, and we have a negative 2i plus I is equal to negative I. So if I write out my final answer, I should have negative 22 minus I. And reminding myself that it needs to be in standard form. So if you need to pause the video, do so now. To process what's going on, pause the video. This is a listening check. This is a listening check. Go ahead and draw a box of cereal. A box of cereal at the bottom of this page. A box of cereal at the bottom of this page. Okay, pause the video. You do, you try, you do. Okay, so hopefully you pause the video, have done the first step out where you distribute that 2 for the exponent to the -3 and the I, and you changed everybody to standard form and distribute your signs. -3 squared is 9. I squared is -1. And we have changed our signs from a negative I to a positive I, and from a +2 to a -2. And then we're going to combine our alert terms by adding everybody up. -9 plus 3 is -6, plus -2 is -8, and -4 plus 1 is -3. That's my final answer. So hopefully you pause the video and you tried that out, because that is all that we're getting into for complex numbers. See you in class for practice.